In this video, you will learn about one of the most important data structure in computer science, stack. A stack is a linear data structure in which the insertion of the new element and the deletion of an existing element both takes place at the same end, that is, at the top of the stack. Think of stack as a stack of plates. We insert new plates on top of another, and when we want a plate, we remove a plate from the top of the stack. This is how stack in data structure works, and because of this property, stack is a last in first out or LIFO data structure. In order to manipulate the stack, there are some basic operations which can be implemented to stack. To insert an element onto the stack, we use push operation. To remove the top element from the stack, we use pop operation. To get the top element from the stack, we use the top operation. To check whether the stack is empty, we use isEmpty operation. To get the size of the stack, we use size operation. Now, let's look at each operation, beginning with the push. As said earlier, push operation adds an element onto the stack. Let's implement push operation in C. We create a new stack using an array of size 10. We create a pointer called top, which always points to top of our stack. We create a new function called push, which takes two arguments, the stack, the top pointer, and the value to be pushed. We first check whether our stack is full. If the stack is full, we print a warning and terminate the process. Else, if the stack is not full, we increment our top pointer, then we place our value onto the stack where our top pointer currently points to. That's it. Our push operation is done. Let's move to the pop operation. Pop removes an item from the stack. Here, the items are popped in reverse order, in which they are pushed. Now, let's implement it. We have our stack and the top pointer. We create a new function, pop, which takes two arguments, the stack and the top pointer. Pop function first checks if the stack is empty. If yes, it prints a warning and terminates the process. If not, it stores the top value of the stack into a variable called value, decrements the top pointer by 1, and returns the variable value. That's it. By now, we have successfully implemented two of the most important operations of stack, push and pop. The rest two operations are top and isEmpty, which are easy. Try to write the code for them by yourself. Basically, the top operation returns the top element from the stack without removing the element, and isEmpty operation checks whether the stack is empty by checking whether the stack is equal to some value. You have to find the value and write your code. I have almost revealed the code. Try it. Now we know what is stack and some operations supported by stack. But why do we use stack? In modern computers, stack is essential for memory management. It acts as a primary management for the running process. Stacks helps in implementing function calls in computers. The last called function is always completed first. You have used the undo and redo features of a program, and we abuse the feature all the time. Guess what? Stacks are used to implement those features. The forward and backward features in the browser is also implemented using stack, and also your clean browse history is stored using stack. Stack is used in string reversal, and the list goes on and on. By now, you might think that stack is best at its work, but hold on. Stack also has a dark side. Stack has a limited capacity as it can only hold a fixed number of elements. If the stack becomes full, adding new elements may result in stack overflow, leading to the loss of data. Stack does not allow for random access to its elements, and it only allows for adding and removing elements from the top of the stack. To access an element in the middle of the stack, all the elements above it must be removed. Stack data structure is not suitable for applications that require accessing elements in the middle of the stack, like searching or sorting algorithms. Stack data structure can result in stack overflow if too many elements are pushed onto the stack, and it can result in stack underflow if too many elements are popped from the stack. While stack data structure supports recursive function calls, too many recursive function calls can lead to stack overflow, resulting in termination of the program. These are the trade-offs we have to do to get the stack we have on your toolbox. Finally, if you found any value in this video, consider hitting that like button. For more videos on DSA, hit that subscribe button. Finally, congratulations on exploring the most important data structure of computer science. Stacks.